Hi ladies, in this video we're going to go through 4K, the theory and questions for 4K, graphs of trigonometric functions, also referred to as circular functions. Now in your textbook we're mostly just doing the angle measured in degrees, but it's the same theory for radians. So instead of being, as you can see here, theta is between 0 and 360. If we were doing it in radian, you would be going from 0 to 2 pi. So the same, your conversion for degrees into radians, you need to understand that. So when you go into year 11 methods, you'll be working more with radians. Now, I haven't got much theory here because just showing you what the graphs look like is probably all you need to know at year 10. But when you move into methods, you're going to come across words like amplitude. Amplitude just means that your graph kind of gets stretched upwards or downwards. So in this graph here, I might use my pen to show you. Come on, work. We're going from 1 to -1. So the maximum point is at 1 and the minimum is at -1, but that can change, and that's your amplitude. Another word you might come across is period. So for this question, our period goes from 0 to 360, but the period can change as well. So just as other graphs change, so a linear graph, y equals x, can change depending on what the gradient and what the y-intercept is. When we did parabolas, they change. So remember the transformations we explored with them. They can go up, down, left, right. They can become narrower or wider. So the same happens with a cosine graph, a trig graph, a sine graph, and a tangent graph. Okay, so just keep that in mind that can happen. But in this video, we're just going to cover the basics for now. Okay, so we might do a second video going through some more complicated stuff. What I've got on the screen now is a cos graph. So you can see it's got cos written there on your y-axis. So this is the graph of y equals cos theta. If I just scroll down for now onto question 3, this is the graph of y equals sine theta. Okay, the main difference, you might think, oh, they look the same. No, sine always starts at 0 and your cosine graph here starts at 1. Okay, so that's the main difference there. And remember when I spoke in the previous videos about the quadrants? So basically, if you think about it, these are the quadrants of your unit circle. So if I just go to this little interactive that you have in your textbook, you can see on the left-hand side we have, I might just zoom in a bit. So we have the unit circle and we've got a set of axes. So on the x-axis, we've got theta. On the y-axis, we've got w, but w is equal to sine theta, cos theta, or tan theta. So if I just quickly, I can't enlarge it and click, so sorry, I have to make it small again. I'm just going to show you the 3 graphs just to maybe overwhelm you and you think, oh my gosh, what is going on? But you can see there the red graph is your sine graph. Then we've got the blue graph is your cosine graph, and then the purple graph is your tan graph. Now, the reason your tan, and you'll probably explore this more next year, not so much this year, your tan is different because remember tan is equal to sine over cos. And what we have here, the dotted, I keep using my arrow knowing that you can't see my arrow when I'm recording. The dotted lines are what we call asymptotes. So your tan graph will never cross these. And the main reason for that, if you look at your cos graph at 90 degrees, it crosses the axis at 0. So effectively, when you divide by 0, it's undefined. So you can't have a value there. That's why there's an asymptote. But we're getting into stuff that's a little bit too complicated for year 10 and just starting out. So let's have a look at the cosine graph. When I start this interactive again, I want you to have a look at the unit circle on the left-hand side. So as the green little ball moves around, you can see the cosine graph being drawn. So there it is. And I'm going to stop it when we get to 90 degrees. Oh, just past 90 degrees. Okay, so remember cos is equal to x. So that's why we've started at 1 and then x equals 1, and then we're moving around at 90 degrees, x is equal to 0. Okay, so at 90 degrees at 0, it's not the same as theta. Okay, so don't make that mistake. The x on this unit circle is not the same as theta on your axes here. All right, so remember, as we move around the unit circle at 180 degrees, I'm getting ahead of myself, x is equal to -1. So we are assuming that the cosine graph is going to go down and the minimum point is going to be -1. So let's just keep going. See, it's moving around the unit circle and I'm going to stop it there. Okay, so x, because it's your cosine graph, remember cos theta is your x, it's at -1 at 180. And then, oh, actually I might just stop it there. And that's half a circle. So when you think about it, we've got 2/4 there, which make up the top half of the unit circle. The reason why we've got 1 above the axis, okay, it's a bit hard without my pointer, but we've got a curve, we start off above the axis. That's because in the first quadrant, cosine is positive. And remember, in the second quadrant, it's negative. That's why it's below. In the third quadrant, it's also negative, so it stays below the axis till we get to 270. Okay, so you can follow the little green ball around your unit circle, and then we keep going until we get back to the end of the circle. So we get to 360. Now, these graphs do continue on unless you restrict your domain. So by domain, it just, what restrictions do we place on the x-axis? So it's only going from 0 to 360, but this graph will just continue going on like that in waves. Okay, let's have a look now at the sine graph. Might just refresh it so we can play it. So your sine graph, remember, sine theta is equal to y. So, oops, I reset it, sorry. So when it starts at 0 degrees, remember y is 0 here on your x-axis. So we start at 0, and then at 90 degrees, y is at 1. Okay, so that's your maximum point there. And then it goes down. Remember, in your second quadrant, it's positive. That's why we're still above the axis. Okay, so we've just done the top half of the unit circle. At 180, your y coordinate is 0. Okay, so we're going to keep going around, and I'm not going to stop it again because you can see it. So the sine graph and the cosine graph are slightly different. If you wanted to, I'll show you the tan graph. So remember, tan is equal to sine over cos, but in year 10, we'll just focus mostly on the sine and the cosine graph. Okay, so there it is. And remember, those dotted lines are referred to as asymptotes. Okay, so when you do methods next year, you'll hear asymptotes used quite a bit. All right, let's get back to the worksheet. So here we have a cosine graph from 0 to 360 degrees. So we're only going to look at one period. So one full rotation of the unit circle. All right, so question 2, use this graph to estimate the value of cos theta for the following. So what we need to do is, remember, we've got theta along here, along your x-axis or your theta axis. So we've got to find 35 degrees. All right, so for 35, now I'm just going to read the grid lines, see how many grid lines we've got. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. So each grid line is worth 10 degrees. So 35 degrees, it's a bit hard to see. It's 10, 20, 30. So there's 35 degrees here. And you just go up until you meet the line. Oh, it's not the straightest. And then we go across. Okay, I'm assuming each one is 0.1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So we're just, I guess, it's it's a bit hard to see, just below 0.9. So we're only estimating, okay? So I'm just going to say approximately 0.9. Okay, it might be a little bit less than that. All right, if we're doing 190, so remember each grid line is 10 degrees. So there's 190 there. So if we go down to our graph, we are just above -1. So it's approximately, or negative 0.98. We're only approximating. If you get pretty close, I mean, if you had the answer 4, you're clearly not anywhere close to 0.098. 330, so I'm going to go backwards this time. So 360, 350, 40, 30. So here's 330 going up. Now that looks like it's about 0.9. Now you can always check what these actually are by putting them into your calculator. So if I just get my calculator up and I'm in degree mode, so what was it, 330? And I don't know whether I'm exact, so let's just do that. So 0.866, which is pretty close to 0.9. Yeah, I'm pretty happy with that. And so you can go on and do the rest of them. Now for part B, this time remember cos theta is written on your y-axis. So here, where are we? So we're going in the other direction now. So instead of reading this from your x-axis, we're reading it from your y-axis. So for the first one, we've got 0.8. So here's 0.8. All right, and then if I go down, oh gosh, there it is. So we just got to read that straight from our graph. So 10, 20, oh God, 10, 20, 30, 40, it's about 45. Okay, so approximately 45 degrees. Now, if you wanted to check, remember to solve for theta, we just use inverse. Oops, wrong one, sorry. They're both blue little tabs. Okay. So what were we doing? 0.8. All right, so I've got 36 point, oh, did I miscalculate? All right, girls, I've just been checking. I think there must be something slightly wrong with this graph because I can't see where I have written it incorrectly. So especially for this first one is also wrong, 35 degrees, but I have read that correctly off the graph. And yes, so I am going to go with the graph is incorrect. And then if we look at B, part I, 0.8 being this purple one going across, it's clearly 45 degrees, but as you could see when I did that on the calculator, it wasn't 45 degrees. So perhaps let's do another one. Okay, so I'm going to do negative 0.4. So let's go down. So we've got 10, 20, 30, 40. So there's negative 0.4. So let's go across. Okay, and then we're going up. So we can go from 90, and remember we're going up 10 degrees. So 100, 110. And there's actually two solutions. So if we kept going, we're actually going to cross the graph again. And remember when we did that on the unit circle in the different quadrants, the different quadrants had different values. So there it is. Its other value. What is that going to be? 260 to around 250. So I'm going to say 250, maybe 3. Okay, let me just check the answers with how we went with that one because we're doing it correctly, but I feel that the textbook, the graph is not drawn entirely accurately, giving us the right answer. So which one did we do? V. 114. 114 and 246. Okay, so we got quite close for 114, but 246. 240, 250, 260. Anyway, so we're pretty much there. That's how you would read it, but girls, usually you wouldn't do this. I think it's just exploring how to get those values. But as long as you can see or read, so if you've got theta and you understand its corresponding value, that's fine. All right, let's move on to the sine graph. So the sine graph is just drawn a little bit differently to the cosine graph. Remember, we start at 0, not at 1. All right, so let's have a look at how we go with this one. So let's start off. I'm not going to do 25 just because I don't want to do halves. I'm going to start off with 100. Let's do 220. So 220. So there's 190, 200, 210, 220. Let's just see if I'm actually counting it right. 30, 40, 50, 60, 70. Okay, so I'm reading the axes correctly. There's 220. Let's go down. And let's go across. Whoops. Maybe that's my problem. I can't draw a straight line. Okay, so we've got points 1, 2, 3, 4, 5, 6. So negative 0.6. And then let's just check that by putting it into the calculator. So sine 220. All right, there we go. So negative 0.6, which is nice. All right, so let's move on to question B. Let's see how we go with part 1. Sine theta equals 0.6. So this time we're on the positive. So we've got 1, 2, 3, 4, 5, 6. So there's 0.6. So remember, we've got 2 solutions. So there's our first one. And going across, there's our second one. So let's just find out what that is. So we've got 10, 20, 30, probably about 33. And then for the second solution, we've got 10, 20, 30, 40, 50, approximately 50. Okay, and let me just check how I went in the textbook. So what are we, 3B? My gosh, I can't read properly, sorry. Why did I do 50? I'm going from 90. So 90 plus 50 is 140 degrees. Silly me, sorry. Can't even read in axes. So at this spot, we're approximately 140, and here we're at approximately 30 degrees. And when you think about it, the 2 angles will add up to 180 because that's how you find them in your unit circle as well. So remember, you've got your reference angle in your first quadrant. So if we were to look at this sine graph, your first quadrant is from here. And your second quadrant, let me just do it in pink, is here. And remember, sine is also positive in the second quadrant. So you're basically, if we had 33 degrees here, then your other angle is going to be 180 minus 33, which gives me 157. But remember, we're estimating it from the graph. All right, let's move on. Hopefully you can go on and do the rest of question 2 and 3. Now, question 4 I wanted to do because I thought it was quite interesting, because you've got to think about, well, where are these points on your graph? Okay, so we've got, for question A, it says sine 60 degrees is greater than sine 200. Now, you can do this by looking at your sine graph and your cosine graph. So if we just did the first one, sine 60, I'll do a cos one because it might be a bit easier with my graph. Let's do cos 310 is equal to cos 50. So we'll go to the cosine graph, 310 and 350, no, 310 and 50. So let's find 310. So 280, 90, 100. So here's 310. And what was the other one? It was 50, wasn't it? I've got a terrible memory. Cos 50, yeah. And so there's 310 and 50 is 1, 2, 3, 4, 5. So there's 50. So we can just go up and then we can go up here. And are they the same? Yes, they are. And you can also think about that in terms of your unit circle. So I'm looking at question G here. If we've got a unit circle, 50 degrees, oh, it's a terrible unit circle, is here. And then let's do cos 310. So 310 being all the way around here, so that leaves that as 50. Now I know that all sine, cos and tan are positive in the first quadrant and only cos is positive in the fourth quadrant, so that is true. Okay, so there's a way of looking at it in terms of the unit circle, but you can answer these also using your trig graphs above. If you wanted to do it on your calculator, you could also graph them, or you could just type sine 60 and put 200 in there. But it's probably best to use the calculator, the graphs to get an understanding of how the graphs actually work. So let's just do A for the fun of it. So sine 60 is greater than sine 200. So I'll go back here, just maybe delete what I've got, so we've got a bit clearer. Okay, so sine 60. All right, so we've got 10, 20, 30, 40, 50, 60. And then 200 is here. So sine 60 is at that point. Sine 200 is here. So sine 60 is greater than sine 200. So that is also true. Okay, so you can draw them like that. Do you have anywhere we got sine and cos? No, they're only comparing sine with sine or cos with cos. All right, the last question I put in because I wanted to show you how to do these on your calculator. So you can use solve, all right, but the problem with solve is if I was to use solve and we're doing the first one, what is it, sine theta equals 0.3. So we're just going to write x equals, instead of theta, 0.3, and we're solving for x. You're going to get a solution like this. And we call this the general solution. And it's probably not going to make much sense to you now. When you do methods, you do need to understand this. But what you can do to restrict it from 0 to 360 is you can just do n solve. So sine x equals 0.3 comma x, and there's your answer. Now the two values, okay, that's the first value. So you can use your knowledge of the unit circle to get the other one. So that would just be 180 minus, so that's your reference angle, so minus that. But another way you can do it is do solve again. Equals 0.3. Now let me just think about where this goes. It's probably not good to be thinking on the spot. So if we go control equals, this sign here means given that. And then we can do x is between 0 and 360. Now, just where this goes, I'm not too sure at this point, so I might have to, no. All right, so I just paused it to see where it would go. So if you see, first of all, I put it within the bracket, okay, and we didn't get the solution we wanted, put the given that outside the bracket. So it's given that 0, and then, so the given that sign is control equals. We'll give you the given that sign and your inequality sign. So you can see there you get your reference angle, 17.457, blah, blah, blah. And then your other one, which I said before was just 180 minus that, which is 162.54. Okay, so that's how you can do it on your calculator. All right, girls, bye.